Imagine a multi-million-dollar offshore oil rig, right? And it just suddenly grinds to a halt.
Oh, total nightmare scenario.
Exactly. The alarm bells are ringing, the pressure is dropping, and the engineers are just scrambling. So they pull up the standard operating procedure,
Naturally.
right, this pristine 500-page engineering manual, and they follow it perfectly. Step A to step B, valve 1 to valve 2.
But I'm guessing it doesn't work.
It doesn't. The rig just stays offline. The manual failed.
Yeah.
And you have to ask why. Well, because the manual didn't know that on this specific rig, after, 20 years of salt and wind, you have to literally kick the secondary pressure valve twice with your steel toe boot to make it seat properly.
The classic unwritten rule.
Exactly. That kick isn't in any textbook. It's unwritten. It's reality. So today, for those of you listening, we are taking a deep dive into how a new technology framework is trying to actually digitize that kick.
It's a huge mission.
It really is. We are uncovering how technology is finally attempting to capture the messy, undocumented reality of complex physical work.
And it is a massive undertaking. To really get into this, we are digging into a stack of technical architecture documents today.
Yeah, lots of dense reading for this one.
Definitely. It's all centered around a July 2026 press release from EON AI Ventures, which is a division of EON Reality.
Right.
They've announced this foundational capability that they're calling verified work episodes. And honestly, what they're attempting to do here really targets the biggest blind spot in enterprise AI today.
Okay, let's unpack this, because knowing you, if you're listening to this, you're probably already familiar with how enterprises are currently trying to solve the AI problem.
Yeah, they just throw data at it.
Right. As we know, general foundation model, no matter how many trillions of parameters they have, they hallucinate wildly in industrial settings.
They do, because they totally lack local context.
Exactly. So most companies try to fix this with R, retrieval augmented generation, where they basically feed the AI all their internal PDFs and manuals. But EON says that isn't enough, because feeding an AI a million PDFs still doesn't teach it how to kick the valve.
No, exactly. RG is great if your company's reality perfectly matches your written documentation.
Which is never.
Right, in heavy industry, manufacturing, aviation, it literally never does. An LLM can ingest every physics textbook ever written. It can read every piece of your company's formal documentation.
It knows the theory.
Exactly. It knows the theoretical chemical properties of the materials you use, but it doesn't know your specific localized equipment configurations, or, the actual degradation of your specific assets out in the weather.
Yeah, the real-world wear and tear.
Right. And it completely misses the highly localized hazards. But most importantly, it completely lacks the expert judgment.
The intuition.
Yes, the muscle memory and intuition of a worker who's been on that exact specific site for a decade.
So it's kind of like having a culinary student, right? A student who has memorized every textbook on food science, but then you ask them to cook your grandmother's secret recipe in her specific kitchen.
Oh, that's a good way to put it.
Right, because the student knows the Maillard reaction, they know the exact chemical composition of butter, but they don't know that your grandmother's oven runs like 20 degrees hot on the left side.
Right, the local context.
Exactly, and they definitely don't know about that unwritten pinch of salt she always throws in right before serving. The student knows the theory, but they completely miss the specific physical reality. So how exactly is EON trying to capture that pinch of salt in an industrial setting?
Well, what's fascinating here is how EON AI Ventures shifts the entire philosophical premise of industrial AI.
How so?
Well, their core argument is that in today's world, the machine, or the foundation model itself, is no longer the scarce asset.
The brain is just a commodity now.
Exactly. You can buy the brain anywhere. The true scarce asset, the thing that actually holds immense value, is the verified ground truth knowledge of how complex work actually succeeds in the real world.
Despite the mud and the noise.
Right, despite the failing equipment and the weather.
I love that concept, but I have to push back on that premise just a little bit.
Go for it.
Haven't companies always meticulously documented their operations? We have standard operating procedures. We have compliance manuals that are practically the size of phone books.
Oh, absolutely. Hundreds of thousands of pages.
Right. We have ISO certifications requiring endless documentation. So hasn't this verified knowledge just been sitting in filing cabinets and on SharePoint drives for the last 30 years? Why is this suddenly a new problem that needs an entirely new AI framework?
That is the exact distinction EON is trying to highlight, actually. There's a massive gulf between a compliance manual and reality.
Okay.
Rulebooks represent theory. A standard operating procedure basically dictates what should happen in a perfect, frictionless world where nothing degrades and nobody ever makes a mistake.
Which doesn't exist.
Exactly.
Yeah.
But EON's framework is built to capture what actually happens. And they are doing this through what they call a verified work episode.
A verified work episode. Okay.
Yeah, they aren't just scanning old safety manuals. They are generating a dynamic system that connects the complete operational story of a job. Like, from the moment a worker gets a work order to the very moment they take off their hard hat.
But wait, if they really want to capture reality, they can't just look at the final product, right?
No, definitely not.
Because if a pump gets fixed, the fact that it's running again doesn't tell you how the mechanic overcame a rusted bolt. They'd have to track the worker's every move. So what exactly is going into one of these episodes?
It is an incredibly dense, multi-layered package of telemetry and context.
Okay.
A verified work episode starts with the intended job and the formal authorization. Then it pulls in the specific asset and the site context.
So that's the baseline.
Right. But here's where it really transcends a normal digital logbook. It actively incorporates the physical reality. It logs the cues noticed by the human worker.
Cues noticed. Wow.
Yeah, the specific decisions they made in the moment, the physical actions taken, the evidence collected via sensors or cameras, the physical outcome of the work, the human assessment of that outcome.
That's a lot of data.
It is. And finally, it captures the explicit approval status, like the permission to actually reuse that specific learning for future work.
So what does this all mean for you listening, right? When you list out all those inputs, the cues noticed, decisions made in the moment, sensor evidence, it sounds to me less like a logbook and much more like the black box on a commercial airliner.
That's a really good analogy.
But instead of just passively recording data so investigators can figure out why a catastrophic crash happened, this system is meticulously recording every single successful flight.
Yes, exactly.
It's figuring out exactly why things went right today, down to the pilot's micro adjustments and gut decisions, so they can basically guarantee tomorrow's flight is just as successful.
That is a perfect visualization. It's literally a black box for everyday operational success.
I mean, I love the concept, but the execution sounds like a logistical nightmare.
Oh, it's incredibly complex.
I get how you record the temperature of a machine or, the torque applied to a bolt with a smart wrench. That's just data. But how on earth do you capture a cue noticed? How does software document a worker's gut feeling?
Well, that brings us to the actual mechanics of the architecture, how they record it.
Right.
To actually generate these verified work episodes, EON uses 4 specific capabilities, they call them capture engines, that all run simultaneously.
Okay, 4 engines.
Yeah, let's walk through how they interlock. First, we have Permit IQ.
Permit IQ.
This engine handles the theoretical baseline we were just talking about. It basically defines what should happen.
The exec.
Right. It outlines the scope of the job, the expected hazards, the required safeguards, any isolation requirements, and the formal authority boundaries.
Okay, so Permit IQ is the rule book. But expectation rarely matches reality, which means they need an engine on the actual factory floor monitoring what the worker is doing.
Exactly, and that is the second engine, Field IQ, along with its offline counterpart, Field IQ Edge.
Field IQ, okay.
This engine captures what actually happened down at the equipment level. It logs the worker's physical actions, any photographs of the site, sensor readings from the tools, and any exceptions to the original plan.
Right, hold on. You mentioned an offline counterpart, Field IQ Edge.
She did, yeah.
Why offline? If we're talking about this cutting-edge AI architecture, shouldn't everything be streaming live to the cloud constantly?
You would think so, but in heavy industry, you frequently deal with what are called intrinsically safe environments.
Intrinsically safe.
Yeah, think of a chemical refinery or a deep underground mine where there are explosive gases present in the air.
Oh, wait.
In those zones, you cannot just bring in a standard iPad or broadcast a strong Wi-Fi signal because a tiny electrical spark inside the device
Could literally ignite the atmosphere.
Exactly. It's a huge hazard. So you have to use specialized, low-power, intrinsically safe equipment. Because of that, there is often zero live connectivity.
Ah, I see.
So Field IQ Edge is designed to gather all this dense physical evidence offline in these dangerous zones, securely encrypt it, and then sync it up to the larger system once the worker returns to a safe zone.
Okay, that makes total sense. So we have Permit IQ laying out the theoretical plan and Field IQ capturing the gritty physical execution, whether that's online or offline.
Right.
But that still doesn't explain how they capture the unwritten kick-the-valve knowledge. How do they capture the tacit stuff?
That is where the third engine, EON Tacit, comes into play.
EON Tacit.
Yes. And this is arguably the most innovative piece of the whole framework. EON Tacit is designed specifically to capture expert heuristics, warning signs, exception handling, and the decision logic that veteran workers use but never fully document.
See, I still don't get how software captures a heuristic. By definition, isn't a heuristic just a mental shortcut?
It is.
It's the mechanic listening to the hum of an engine and just knowing the timing belt is off by a millimeter. You can't plug a USB cable into a 30-year veteran's brain.
No, you can't. But if we connect this to the bigger picture of how these engines interact, you actually don't need to plug into their brain.
Really?
Yeah. EON Tacit finds the unwritten knowledge by mathematically measuring the gap between the theory and the reality.
The gap.
Right. The system constantly compares permit IQ, what the manual said to do with field IQ, what the veteran actually did.
Oh, okay. Give me an example.
Let's say the manual says, turn the pressure valve exactly 90 degrees, but field IQ registers, via a smart wrench and acoustic sensors, that every time a veteran worker does this job, they stop at 75 degrees.
Why 75?
Because maybe a specific high-frequency hiss starts echoing in the pipe at that exact moment.
I see where this is going. The system flags the gap.
Precisely. When an experienced worker deviates from the standard operating procedure, and the job is ultimately successful, the system doesn't flag that deviation as a compliance error.
It doesn't write them up.
No, it flags it as a heuristic, a gut feeling put into action. EON Tacit captures the acoustic data of the hiss, which is the cue notice right before the worker stopped at 75 degrees, which is the decision made.
Wow.
By analyzing that delta between the manual and the worker's action, the software actually maps out the unwritten reality.
That is incredible. But wait, learning a new unwritten rule doesn't do you any good if you can't test it safely.
Very true.
If the AI suddenly decides, hey, the new rule is 75 degrees, how do they know that implementing this new shortcut across the whole company won't inadvertently blow up a factory somewhere else?
That exact safety concern is why the fourth engine exists. And they call it the situation room.
Situation room.
Sounds intense. It is. Because you can't just blindly push a newly discovered heuristic into production. The situation room takes all this gathered data, especially rare events, abnormal conditions, and these newly discovered worker shortcuts, and turns them into repeatable, simulated scenarios.
Like a digital testing ground.
Exactly. It allows the enterprise to test consequences and counterfactuals. Before you rewrite the manual, you simulate how different workers or automated systems would handle that 75-degree valve turn in a safe, digital environment. And it's all powered by real, verified past episodes.
Okay, so we have a clear pipeline here. Permit IQ sets the plan. Field IQ captures the reality. EON Tacit extracts the unwritten rules by comparing the two, and the situation room safely tests those new rules.
You got it.
But honestly, if I'm the VP of operations at a massive global energy company, this sounds like an absolute nightmare of data management.
Oh, the volume of data is staggering.
Right. You were talking about streaming acoustic data, smart wrench torque logs, video feeds, and biometric data from thousands of workers every single day. A fire hose of raw data is practically useless. It just buries you. So how does EON process this without completely overwhelming the enterprise?
That's a critical point.
Yeah.
Because data without structure is just expensive noise.
Exactly.
The journey from raw field evidence to trusted, deployable intelligence happens in what EON calls their intelligence refinery.
The refinery.
Yes, and it's a multi-stage mechanism. First, that fire hose of raw data goes through assess IQ.
Okay.
This engine's job is purely to reconstruct the performance of the job and mathematically measure what they call the operational delta.
The gap we talked about.
Right, the exact quantified gap between the planned procedure and the actual physical execution.
So assess IQ is basically the auditor. It just highlights the differences.
Exactly. Then that audited data moves into compound IQ, and this is where the heavy machine learning really comes in. Compound IQ looks at the macro picture across the entire enterprise. It uses advanced statistical models to sift through thousands of sensor logs and edge data to identify recurring patterns.
So it connects the dots globally.
Right. If one mechanic in Texas turns the valve to 75 degrees, it's just a localized anomaly. Maybe his wrench is broken,
Sure.
But if Compound IQ's algorithms detect that 50 different veteran mechanics across 3 different continents are all stopping at 75 degrees when the acoustic sensors register that specific hiss,
It identifies a statistically significant unwritten standard.
it finds the signal in the noise, it realizes the manual is globally wrong.
That is wild.
But even then, an AI doesn't get to just unilaterally rewrite company policy. Everything finally passes through the EON and distillery.
The distillery.
Yeah, this is the governance layer. It applies strict version control, ownership rules, and human-in-the-loop approval workflows.
So humans still have the final say.
Absolutely.
Yeah.
Only after a human subject matter expert reviews the data and officially approves the learning through the distillery does it actually become verified intelligence. And once approved, that learning updates the company's digital twin.
Let's pause and define that for a second just to be super clear for the listeners. When they say digital twin, they mean a highly accurate virtual replica of their physical assets and processes, right? Like a digital simulation of the factory floor.
Exactly. A living digital model that now reflects how the factory actually operates, rather than how it was originally designed to operate on paper.
Right.
And that updated intelligence then flows back down to revise standard procedures, improve worker training, or build better mission packages for the next job.
Here is where it gets really interesting from a technical side, looking at how they actually built this.
Right.
Because the press release explicitly states that this entire architecture is model independent, meaning EON is not trying to build one giant proprietary godlike foundation model to process all of this. They intentionally separate the intelligence, which are the AI models, from the knowledge, which is the company's proprietary data.
That is perhaps their most significant strategic decision.
Really?
Oh, definitely. In the current AI landscape, companies are terrified of handing their most valuable proprietary data over to big tech companies.
Right, because if we go back to our kitchen analogy for a second, it's like a restaurant keeping your grandmother's priceless secret recipe book completely private, locked away in your own kitchen vault.
I love this.
Right. And when you need to chop onions or measure ingredients, you just hire whatever Michelin star chef is currently the best in the world. They come in, they do the specific reasoning or perception work, and then you kick them out before they ever see the secret ingredients.
That's spot on.
EON's system is the kitchen vault. You can plug in the best available AI model from anywhere in the world to do some math, but the AI never gets to own your gold.
It perfectly protects the enterprise from vendor lock-in and data leakage. Think about it. If a vastly superior reasoning model is released by a new startup next Tuesday, EON can just swap it in via API.
Seamlessly.
Right. The enterprise doesn't lose a single byte of its historical verified knowledge, and the learning loop remains entirely under the company's governance.
So bringing this all back down to earth, we've mapped the architecture, we know how the engines capture the unwritten rules, and we see how the refinery governs the data.
Yeah.
But I want to ask the ultimate what question for you listening. Why would a massive enterprise invest tens of millions of dollars and years of capital into building out this massive infrastructure? What is the actual tangible payoff for capturing these verified work episodes?
Well, the enterprise value addresses an existential crisis in heavy industry right now, which is the demographic cliff.
The retiring workforce?
Exactly. The most experienced workers are retiring at an unprecedented rate, and they're taking decades of tacit knowledge. All those unwritten heuristics out the door with them.
Just gone.
Just gone forever. So this system is a frantic effort to capture and digitize that expertise before it's too late. But beyond that, it vastly improves the safety and execution of the current workforce.
By sharing the knowledge.
Yes. By learning from every completed mission, it reduces repeat mistakes and ensures that a junior worker in Brazil can instantly benefit from a hard-learned lesson discovered by a veteran in Norway yesterday.
So it basically acts as an omnipresent support system for human workers today.
It does. But this raises an important question because there is a secondary, longer-term layer to this.
Okay, what is it?
This governed intelligence is explicitly designed to support robots, drones, AI agents, and autonomous systems as their physical capabilities mature.
Ah.
The verified work episodes they are gathering today are quite literally the training data for the autonomous workforce of tomorrow.
Okay, this raises a really important tension here, and I have to challenge this narrative.
Let's hear it.
You read the press release, right? And EON frames this as transforming operational experience into trusted work intelligence for humans and machines. They use all this lovely corporate PR speak about elevating the worker and giving them better preparation.
They do, yes.
But let's be fiercely realistic here. If EON is meticulously capturing a veteran worker's gut feelings, their unwritten rules, and undocumented genius specifically to train robots, are these human workers essentially just training their replacements?
It's a heavy question.
Right. Because once an autonomous drone perfectly learns the veteran's 75-degree valve trick, why pay the veteran? Is this ultimately a tool designed to replace them by downloading their brains first?
It is honestly the most pressing ethical and economic question surrounding industrial AI, and your skepticism is entirely warranted.
I mean, it's hard not to see it that way.
The corporate narrative is absolutely focused on partnership and safety. They argue the immediate, urgent need is to help the current human workforce operate more safely. To prevent catastrophic accidents by giving them perfect information today.
Sure, safety first.
Right. And the deployment of robots and drones is presented merely as an evolution for tasks that are too dangerous or repetitive for humans anyway.
But the underlying reality is that by perfectly mapping what actually happens on the floor, we are finally documenting the undocumented genius of the human worker. We are literally translating human intuition into machine code.
Precisely.
Mhm.
And while the immediate benefits to industrial safety and productivity are undeniable, it leaves us with a profound, almost uncomfortable long-term implication.
Which is?
Well, the entire premise of verified work episodes is to capture the highly subjective cues noticed and decisions made by human experts, digitize them, and feed them into autonomous systems.
Right.
So if this intelligence architecture perfectly maps every human heuristic, every brilliant shortcut, and every previously undocumented gut instinct—
It captures the magic.
Exactly. Do human experts inadvertently program their own obsolescence simply by doing their jobs exceptionally well? Or, on the flip side, does this system actually elevate humans to purely strategic oversight, finally freeing our species from the dangerous, back-breaking physical execution of complex labor?
It's the ultimate paradox of automation, isn't it? We are racing to capture the absolute magic of the human touch solely so the machine can perfectly mimic it.
It really makes you wonder what the floor of a factory looks like in 20 years.
It does. Are we looking at the twilight of human mastery in the physical world? Or is this the dawn of an era where humans just safely call the plays from the Situation Room? For those of you listening, we will leave you to chew on that paradox. Thanks for joining us on this deep dive.